Hi dear students, today's session is about model questions for SSC JE as well as for RRB JE. Okay? We will see. Before I am going to discuss the questions for RRB JE and SSC JE, let me tell you from which areas they will focus more from this subject. Mostly questions will ask from IS codal specifications, IS codal specifications, IS codal specifications. First priority given for codal specifications. Coming to the second priority, definitions. Second priority given for definitions. And third priority given for concepts. Okay. We will see questions, model questions for SSC JE and RRB JE. Mostly questions are straightforward. Okay. You can pick up the answer within 1 or 2 steps, or sometimes directly we can pick up the option. Okay. We will see. Question number 1, you check it. What is given here? As per IS 456-2000, the minimum nominal cover for beams is, just a minute. Okay. Minimum nominal cover for beams, they are asking for beams. What is nominal cover? Can take beam here. This is stirrup. This is stirrup and this is mainstay, right? And you measure the depth of concrete from extreme concrete phase 2 till face of the stirrup. This is nominal cover. Okay. So this nominal cover they are asking, nominal cover for beams. It is 25 mm, minimum nominal cover for beams will be 25 mm. Okay. Coming to the next question. As per IS 456-2000, the minimum nominal cover for slabs it is 20 mm. The minimum nominal cover for slabs is 20 mm. For beams 25 mm, for slabs 20 mm. Coming to the next question, as per IS 456-2000, the minimum nominal cover for columns, what will be the minimum nominal cover? Actually it is a 40 mm or diameter of the bar, 40 mm or diameter of longitudinal bar, whichever is maximum, right? And one more case is there, that is, if least side of the column less than or equal to 200 mm, least side of column less than or equals to 200 mm, then minimum cover 25 mm. Minimum cover we can provide 25 mm. If least side of column is more than 200 mm, then minimum cover should be 40 mm. Minimum cover should be 40 mm. Okay, na? Is it clear? But here they have not mentioned any size of the column. Simply they are asking what is the minimum nominal cover required. So 40 mm. You pick up directly 40 mm. Fine. Coming to the next question. As per IS 456-2000, the minimum nominal cover for footings will be, for footings minimum nominal cover provided 50 mm, minimum 50 mm. Okay. For beams 25 mm, for slabs 20 mm, for columns 40 mm and for footings 50 mm. You can expect one question from nominal cover. Okay. Maybe it is asked for beams or for slab or for column or for footing. Coming to the next question. As per IS 456-2000, the area of minimum tension reinforcement in beams is minimum tension reinforcement. In beams, AS upon BD equal to 0.85 upon Fi. If you observe options, they have given AS upon BD equals to 0.85 upon Fi. Option B is correct. Option B is correct. Coming to the next question. Next question. As per IS 456-2000, the area of minimum shear reinforcement in beams, minimum shear reinforcement provided in beams from the formula ASV upon BSV greater than or equal to 0.4 upon 0.87 Fi. But here given worst case equal to, nothing wrong. So, ASV upon BSV equal to 0.4 upon 0.87 Fi. Option B correct. You check it. 0.4 upon 0.87 Fi. Only one option here. Option B correct. Coming to the next question. As per IS 456-2000, the area of maximum tension reinforcement for beams maximum tension reinforcement. My dear, it is not more than 4% of gross cross sectional area. In beams, this is neutral axis, this is compression zone, this is tension zone. On tension zone, maximum how much steel you can design? We can design maximum 4%. Okay, right. So, not more than 4% of gross cross sectional area. Option C is correct. Option C correct. Even in compression zone also, maximum steel not more than 4% of gross cross sectional area of beam. Compression steel also not more than 4% of gross cross sectional area of the beam. So, option B, option C is correct. Coming to the next question. As per IS 456-2000, the area of maximum reinforcement for slabs, not for beams, it is for slabs. Even for slabs also, maximum reinforcement should not be more than 4% of gross cross sectional area of slab. So, 4% of BD, option B correct. Option B correct. Next question. As per IS 456-2000, the area of maximum compression reinforcement for beams, here given already, compression reinforcement for beams, same 4%. In tension zone, we provide 4% maximum steel. In compression zone also, maximum steel you can provide 4% only. If you provide more than 4%, then practical difficulties arise, such as compaction of concrete, placing of steel, these are difficult. Okay. So, do not cross maximum steel limit. Next question. As per IS 456-2000, the area of minimum reinforcement for slabs if mild steel used in design is, my dear, if you select AS minimum, if you select mild steel for design, if you select mild steel, minimum steel should be 0.15% of BD. AS minimum. If you select HYST bars, minimum steel should be 0.12% of BD. Suppose if you select mild steel in design, if you select HYST bars in design, 0.12% of BD. Okay. So, mild steel 0.15% of BD. Option B correct. Option B correct. Okay. Right. Next question. As per IS 456-2000, the area of minimum longitudinal reinforcement for columns is, columns, minimum reinforcement, that too they are asking in columns. In columns, the minimum reinforcement should not be less than 0.8% of gross cross-sectional area of the column, right. Suppose if you take a rectangular column, then gross cross-sectional area becomes BD. Here 0.8%, 0.8% given, 0.8% of gross cross-sectional area. Next question. As per IS 456-2000, the area of maximum longitudinal reinforcement for column is maximum reinforcement in columns. My dear, it should not be more than 6% of gross cross-sectional area of the column, 6% of gross cross-sectional area of the column, okay, maximum reinforcement in columns. Next question. As per IS 456-2000, the area of maximum longitudinal reinforcement for column, a repeated question. Option C, it is 6%, previously given. Option not pick up, right? Option C correct, longitudinal steel, okay, repeated question. Next question, maximum spacing. Before I will move to the next question, let me tell you one question compulsory based on minimum steel and maximum steel, based on minimum steel and maximum steel. From these two, one question compulsory in exam. Maybe that minimum steel they will ask for beam, or they will ask for slab, or they will ask for column. Similarly for footing, maximum steel also maybe they will ask for beam, or they will ask for slab, or they will ask for column, okay. But one question compulsory based on the reinforcement, minimum or maximum. Based on cover, one question. Based on steel, one question you can expect in exam, okay. Then come to the next one. As per IS 456-2000, the maximum spacing of main reinforcement in beams, they are asking maximum spacing of main reinforcement. In beams we can provide two types of reinforcement. You can see longitudinal section, maybe you will understand easily. This is longitudinal steel, this is longitudinal steel, okay. See the cross section, this is longitudinal steel. They are asking what is the maximum spacing. Maximum spacing for main steel, whether it is a tension zone or it is a compression zone, it should not be more than 300 mm, not more than 300 mm, center to center, from center of the bar to center of the bar, should not be more than 300 mm, from center of the bar to center of the bar, should not be more than 300 mm, okay, right. So option C is correct, maximum spacing, okay. Then what about minimum spacing? Minimum spacing for main reinforcement in beams based on three conditions. One is diameter of the bar. If you design same diameter like 20 mm, 20 mm, 20 mm, or maximum diameter of the bar, suppose if you design combination 20 mm, 20 mm, 16 mm, in that case you can take the gap between two bars is maximum diameter of the bar. And third one is 5 mm plus maximum size of coarse aggregate, 5 mm plus maximum size of coarse aggregate used in RCC. So finally you can select maximum of the three, okay. This is minimum spacing for main steel in beam, but maximum spacing they are asking, it is not more than 300 mm center to center. Option C is correct. Next question. As per IS 456-2000, the maximum spacing of shear reinforcement in beams subjected to torsion. Beams subjected to torsion. When beam subjected to torsion for stirrups, maximum spacing should not be more than x1 should not be more than x1 plus y1 upon 4 should not be greater than 300 mm. Take among the three smaller one. Maximum spacing is smaller of the above three conditions. Option D correct. Smaller of the above value. Option D correct. Okay. For stirrups, when beam is subjected to torsion, maximum spacing should not be more than x1, not more than x1 plus y1 upon 4, not more than 300 mm. Okay. Whichever is smaller, that value is adopted finally. Okay na? Come on. Next question. Move to next question. As per IS 456/2000, the maximum spacing of vertical stirrups in beams. My dear, there are two cases. One is beam subjected to flexural shear and a beam subjected to torsional shear. When beam subjected to torsional shear, they will mention in the question, beam is subjected to torsion like that. Previous question is the example. But in this question, they didn't mention flexural shear. Simply they are asking what is the maximum spacing provided for vertical stirrups. So, it will be comes under flexural shear. For this case, maximum spacing should be 0.75D or 300 mm. 0.75D or 300 mm, whichever is smaller, Here given that option smaller of 0.25D or 300 mm, B 0.5D or 300 mm, option C given 0.75D or 300 mm, option D given D or 300 mm, right. Option C correct, because they have given here vertical stirrups. Suppose in the question, if it is given inclined stirrups, then maximum spacing for inclined stirrups will be D or 300 mm, whichever is smaller. For vertical stirrups, 0.75D or 300 mm. For inclined stirrups, D or 300 mm, whichever is smaller. Okay? Fine. Where D is effective depth of the beam. Coming to the next question. As per IS 456/2000, the maximum spacing of main reinforcement in slabs. In slabs, what will be the maximum spacing you can provide for what? For main reinforcement. My dear, for main reinforcement, maximum spacing should be 3D or 300 mm, whichever is smaller. 3D or 300 mm, whichever is smaller, where small d is the effective depth of the slab. Here given option 3D or 300 mm. Option C is correct. Maximum spacing of main reinforcement provided in slabs. 3D or 300 mm, whichever is smaller. Next question, ma. As per IS 456/2000, the maximum spacing of distribution reinforcement in slab, what will be the maximum spacing we provide for a distribution reinforcement? It is 5D or 450 mm as per old data. Later on it is modified, it is not 450 mm, it is modified to 300 mm, 5D or 300 mm, whichever is smaller. The maximum spacing for distribution steel should be 5D or 300 mm. Option C is correct. Okay? Fine. Next question. As per IS 456/2000, the pitch of lateral ties in columns is least lateral dimension of column 16 times the diameter of longitudinal bar, 300 mm, smaller of the above. Yes, my dear, the pitch or spacing between lateral ties should be least lateral dimension of column or 16 times diameter of smallest longitudinal bar or 300 mm. Take a smaller value, among the three conditions, take a smaller value. For lateral ties, what will be the pitch you can maintain? Maximum pitch should be least lateral dimension or 16 times diameter of smallest longitudinal bar or 300 mm. Option D correct. Smaller of the above. ABC given, in that ABC, smaller value will be the maximum pitch. Okay. Next question. As per IS 456-2000, the maximum pitch of helical reinforcement in columns. My dear, helical reinforcement, what will be the pitch? It should not be more than 75 mm. It should not be more than 1/6 of core diameter. It should not be less than 25 mm. It should not be less than 3 times of diameter of helix. So, maximum how much you can provide? 75 mm. Maximum you can provide 75 mm. Minimum 25 mm. Pitch of helical reinforcement you can maintain maximum 75 mm, minimum 25 mm. Okay? Right. Next question. Yeah, before I will explain this question, let me tell you one question you can expect based on spacing. Based on spacing, one question you can expect, right? Maximum spacing in beams, maximum spacing in slabs, maximum spacing in columns, right? Based on spacing, one question you can expect in exam. Clear? Right. Next, come to this one. As per IS 456-2000, the minimum number of longitudinal bars in a rectangular column is clearly mentioned that rectangular column. Rectangular column. So, for rectangular column, minimum 4 numbers. You can provide 1 at each corner. 1, 2, 3, 4. So, minimum 4 numbers. For a rectangular column, you can provide minimum 4 longitudinal bars, 1 at each corner. Next question. As per IS 456-2000, the minimum number of longitudinal bars in a circular column is, my dear, in circular column, minimum 6 numbers. This is column. My dear, 6 numbers na, 0, 60, 120, 180, 240, 300, angle 360 degrees divided by 6 bars. So, 60 degrees you can maintain between 2 bars. So, minimum 6 numbers in circular column. Along the periphery we can provide, and in a rectangular column minimum 4. Mostly you can expect in the exam for circular column. For circular column minimum number 6. Okay? Next one. As per IS 456-2000, the minimum diameter of longitudinal bar in a RC column. In columns, what will be the minimum diameter of bar you can provide for longitudinal steel? Minimum diameter should be 12 mm. It should not be less than 12 mm. At least 12 mm you can maintain. For avoiding buckling, minimum 12 mm diameter you can maintain for longitudinal steel. So, 12 mm. Option A correct. Next question. As per IS 456-2000, the maximum diameter of bar used in RC slab, this time slab, diameter is maximum dia. My dear, maximum diameter of bar, not minimum dia, maximum dia. Maximum diameter of the bar used in slabs should not be more than 1/8 of overall thickness of the slab. 1/8 of overall thickness of slab. Given option A, 1/4 of thickness of slab, 1/2 of the thickness of the slab, 1/8 of the thickness of slab. Option C correct. So, from these two you can expect one question. Maybe you can expect a slab, that is maximum diameter of the bar used in slabs, my dear, not more than 1/8 of thickness of the slab. Otherwise, you may expect minimum diameter of the longitudinal bar used in column, 12 mm. Okay? Next question, ma. As per IS 456-2000, the minimum thickness at the edge of footing when footing is resting on soil. This is footing, right? This is column. Now, footing is resting on soil. For this footing, this is the edge, this is the edge. So, minimum thickness at the edge of footing should be 150 mm. Minimum thickness at the edge of footing should be 150 mm. Option B is correct. Option B correct. Next question. As per IS 456-2000, the minimum thickness at the edge of footing when it is resting on piles. If it rests on piles, minimum edge thickness should be 300 mm. Sometimes they don't mention in question whether it is resting on soil or resting on piles. Simply they will give minimum thickness of the footing required at the edge as per IS 456-2000. We have two values, 150 mm and 300 mm. Least value is 150 mm. So, pick up 150 mm. Okay? Next question. Excuse me. As per IS 456-2000, the minimum number of double bars provided in footing, minimum 4 double bars, minimum number of double bars 4, minimum number of double bars you can provide 4, okay? And number regarding diameter, maximum diameter of double bar should not be more than column bar dia plus 3 mm, column bar dia plus 3 mm, and minimum area of double bars not less than 0.5% of column area, and the function of double bars is transferring column load to the footing safely. Okay, option for this question number only they are asking 4. Next question. As per IS 456-2000, the minimum area of double bars used in footings, just now we have discussed minimum area should be 0.5% of column area, at least 0.5% we can maintain. Area of double bars should not be less than 0.5% of column area, 0.5% of column area, not column bars area, column area. Next question. As per IS 456-2000, the minimum number of longitudinal steel bars provided in a beam subjected to torsion. When beam subjected to torsion, provide minimum 4 longitudinal bars. In beams, provide minimum 4 longitudinal bars, 1 at each corner, okay, when beam is subjected to torsion. Next one. As per IS 456-2000, the anchorage value of tension steel with 90 degrees bend, my dear, 90 degrees bend for tension steel, for each 45 degrees bend, code recommended provide anchorage value 4 times diameter of the bar. Here given 90 degrees bend, 90 degrees means 45 plus 45. So, 8 times bar diameter, 8 times bar diameter for 90 degrees bend. Okay, that is only for tension steel, only for tension steel. For each 45 degrees bend, code recommended provide anchorage value 4 times the diameter of the bar. Okay. Next, as per IS 456-2000, the anchorage value of tension steel with the standard U-type hook is, my dear, this is 90 degrees bend. For this, we can provide anchorage value 8 times diameter of the bar. Standard U-type hook means 180 degrees bend, like this, 180 degrees bend. For this one, anchorage value we can provide 16 times the diameter of the bar, 16 times diameter of the bar. Option D correct, option D correct. Okay. Next question. As per IS 456-2000, the anchorage value for stirrup, not for tension steel, it is for stirrup. For stirrup with 135 degrees bend, my dear, for 90 degrees bend, anchorage value 8 times dia, anchorage value, angle of bend, anchorage value. For 135 degrees bend, it is 6 times dia. For 180 degrees bend, it is a 4 times dia. Okay? Here given what? 135 degrees bend, so option B correct, B correct. Okay? Next question. As per IS 456-2000, for the reinforcement splicing should not be done if the bar diameter more than, my dear, if bar diameter more than 36 mm, don't go for splicing. This is old data. This is old data. Wrong now. My dear, later on it is modified to 32 mm, not 36. 32 mm is the correct answer. When bar diameter is more than 32 mm, go for welded joints. Splicing joint not recommended. Welded joints are preferred. Okay. Option C. But you observe 32 is there, 36 also available in options. Okay. Pick up 32. Latest information is 32, not 36. Next one. As per IS 456-2000, for the reinforcement splicing should not be done where the bending moment more than, there is a limitation. If bending moment is more than 50% of moment of resistance, in that region don't go for splicing. Where do you go for splicing? If bending moment, wait. Yeah, if bending moment is more than 50% of moment of resistance, don't go for splicing. Where do you go for splicing? If bending moment less than or equal to 50% of moment of resistance. In which region we go for splicing? Where bending moment is less, there you can provide splicing. If you provide splicing joint where bending moment is more, chances are more to break the joint. Okay. So, option given here 50% of moment of resistance where the bending moment more than, splicing should not be. Okay, should not be. It's okay, 50% of moment of resistance. More than 50% not recommended. Don't go in that zone splicing. Okay na? Next question ma. As per IS 456-2000, the bond stress of deformed bars when compared to mild steel bars. My dear, tau BD, if you take tau BD, this is for mild steel in tension zone. Suppose if you use HYSD bar instead of mild steel bar, if you use HYSD bar, same in tension zone, the bond stress is 60% higher compared to mild steel, if you take HYST bar, the bond stress is 60% higher, okay, 60% more, 60% more. Similarly, if you take in tension zone for mild steel, in tension zone it is tau BD. Same mild steel, if you provide in compression zone, then bond stress is 25% more. Bond stress is 25% more. Here 25% more in compression zone. For a HYST bars, bond stress 60% more. Okay na? Right. Option D correct. Next question ma. As per IS 456-2000, the pH value of water should not be less than, commonly asking question, should not be less than 6, should not be less than 6. Sometimes they will give range. When range given, pick up 6 to 8.5. If range given. If range not given, then pick up should not be less than 6. Okay na? Right. Option B is correct. The water used in construction for mixing and curing, right? It should be clean, it should be clean, whose pH not less than 6. Okay? Next question. As per IS 456-2000, the flexural tensile strength of concrete is, my dear, flexural tensile strength also called modulus of rupture. Flexural tensile strength is also called modulus of rupture. SIR means what? Suppose you take a beam, right? This is compression zone, this is tension zone. Let us say this is compression zone and this is tension zone. My dear, in tension zone for concrete, what is the permissible limit? Under bending, what will be the tensile strength of concrete? That is what? Flexural tensile strength. My dear, option 0.7 root FCK, 0.7 root FCK, FCR, FCR equal to 0.7 root FCK. Maybe they will ask formula, or sometimes they will ask a simple numerical question. Just by giving grade of concrete. For M25 grade concrete, what is the flexural tensile strength? Like that they will ask. My dear, flexural tensile strength will be 0.7 into root FCK. For M25 grade concrete, FCK is 25 Newton per mm square. So it is 0.7 root 25, you may get 3.5 Newton per mm square. Okay na? Maybe they will ask numerical question or simple formula. Next, as per IS 456-2000, the modulus of elasticity of concrete is, concrete this time not flexural tensile strength, modulus of elasticity, EC value they are asking, it is 5000 root FCK. Maybe they will ask formula, or they may ask a simple numerical question. 5000 root FCK. Option D correct. Okay. My dear, again I will take M25 grade concrete and they will ask modulus of elasticity. You can substitute 5000 root FCK. So you may get 25,000 Newton per mm square. Khatam. That's it. Okay na? Maybe formula or simple numerical question you can expect. Next question. The thermal expansion coefficient of steel. They are asking coefficient of thermal expansion. For steel and concrete is nearly same. This value is 12 into 10 power minus 6 per degree centigrade. Okay, is it clear? The coefficient of thermal expansion. Why do we select steel only? Why not other material? It is the main reason. The coefficient of thermal expansion for steel and concrete is nearly same. That's why we can select steel as a reinforcement in RCC. Next question. As per IS 456-2000, the modulus of elasticity of concrete, repeated question, right? 5000 root FCK. Next question. Which one of the following predicts the effective modulus of elasticity? You can say long term modulus or effective modulus, meaning same, that is EC upon 1 plus theta. What is EC? EC is 5000 root FCK, 5000 root FCK upon 1 plus theta. Which option? Option A is correct, my dear. Option A is correct. Okay, na? Option A is correct. Next question. As per IS 456-2000, the nominal maximum size of course aggregate should not be greater than, according to IS code, maximum size of course aggregate should not be more than 1/4 of thickness of the member. Should not be more than 1/4 of the thickness of the member, maximum size of course aggregate. But in RCC, maximum size of course aggregate used 20 mm. In general, maximum size of course aggregate used in RCC is 20 mm. Okay. Next question. Wait. Here 1/4 of thickness of the member. Option A correct. Next question. As per IS 456-2000, the minimum grade of concrete used for RCC structures, my dear, for RCC, minimum grade of concrete used in general construction is M20. General construction is M20, but in coastal region, minimum grade of concrete is M30. Minimum grade of concrete used M30. You check it in question whether it is given coastal region or simply they are asking minimum grade of concrete. You check it in the question, nowhere it is mentioned that coastal region or the structure subjected to sea spray, like that, not mentioned anything. So take it M20. M20 is the minimum grade of concrete. Next question. As per IS 456-2000, the minimum grade of concrete used for RCC structure in coastal region, just now I told, M30. M30. Okay. Next question. As per IS 456-2000, the design strength of concrete for beams and slabs. My dear, design strength of concrete FC is 0.446 FCK. This is a bending strength. Suppose for concrete in columns, will be 0.4 FCK. This is axial strength, axial compressive strength of concrete. It is a bending compressive strength, it is axial compressive strength of concrete. Okay. This is in columns, this is in beam, slab, even footings. Okay, na? Right. Option 0.45 FCK, because they have given beams and slabs. Next question. As per IS 456-2000, the permissible bearing strength of concrete at the base of column footing is, what is the permissible bearing stress? My dear, it is 0.446 FCK, or you can say 0.45 FCK under limit state method, whereas under working stress method, permissible bearing stress is 0.25 FCK. If it is working stress method, they will mention in the question. But given here IS 456-2000, my dear, try to understand this is limit state method. So under limit state method, permissible bearing stress is 0.446 FCK, that is 0.45 FCK. Option A is correct. Okay. Next question. as per IS 456-2000, the design strength of tension reinforcement in beams. How do you get design strength? Design strength is equals to Fy upon partial safety factor for steel. This value is 0.87 Fy. Sometimes, wait a minute, I will go back once. Sometimes they are asking design strength 0.67 FCK upon partial safety factor for concrete. They are asking what is the strength of concrete in a structure as per IS 456-2000, what is the strength of concrete in a structure? It is 0.67 FCK, okay, right. This 1.5 is the partial safety factor for concrete. Now 1.15 is the partial safety factor for steel under limit state method, okay. Now which option? 0.87 Fy. Next, actually in limit state method 0.87 Fy. In working stress method it is 0.55 Fy. 0.55 Fy in limit state method and in working stress method. Next one, next question. As per IS 456-2000, the maximum shear stress allowed into the concrete. They are asking what is the maximum shear stress you can allow? 0.62 times root FCK. Tau C max. Tau C max. You know, my dear, tau C max depends on only concrete grade. 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 Whereas tau C is there, na? This tau C depends on concrete grade and tau C depends on concrete grade and percentage of tension steel. Depends on concrete grade and percentage of tension steel, okay. My dear, yeah, as per IS 456-2000, a simply supported beam is said to be a D beam when the ratio of effective span to overall depth. My dear, for simply supported beam, L by D ratio not greater than 2, then it is a D beam. Sir, suppose L by D ratio less than 2, L by D ratio greater than 2, then it is a shallow beam or normal beam, right. Option A correct. Next question. As per IS 456-2000, a continuous beam is said to be a D beam when the ratio of effective span to overall depth should not be. My dear, for continuous beam, L by D ratio not greater than 2.5, then it is a D beam. Suppose if it is greater than 2.5, then it is a normal beam. Next question. As per IS 456-2000, the effective span of a cantilever beam. My dear, for cantilever beam, it is L plus Bs by 2 or L plus D by 2, whichever is smaller. Whichever is smaller. Here they have given that clear span plus half the width of the support, correct. Clear span plus effective depth, no. Clear span plus width of support, no. Clear span twice. So option A correct. Next question. As per IS 456-2000, the effective span of a simply supported beam. For simply supported beam, it is L plus Bs or L plus D, whichever is smaller. So clear span plus width of support, clear span plus effective depth. Third, fourth, smaller of third and fourth. Option C correct. Next question. As per IS 456-2000, the factor of safety of steel and concrete in elastic method, not in limit state method, in elastic method. For steel it is 1.78 and for concrete it is 3. My dear, 1.8 and 3. Option C is correct. Coming to the next question, as per IS 456-2000, the partial safety factor used for steel and concrete in limit state method. My dear, in limit state method, first given steel 1.15 and 1.5. Option A correct. Okay. Next question. As per IS 456-2000, a column is said to be a short column. My dear, if lambda not greater than 12, short column. If lambda greater than 12, then it is a long column. Okay, fine. Like this, my dear, you can expect questions mostly in JE, whether it is SSC JE or RRB JE, questions are straightforward. Okay, you just go through my notes. Mostly questions will come from notes only, right? I don't say that 100% questions, but majority of the questions you can expect from notes, because we have covered the syllabus and also we have covered questions from previous year, last 10-15 years. You check it, same model questions are repeating, right? Okay, thank you. I wish you all the best.